Good morning, guys. It's Friday, October 24th. Hope the quiz went well yesterday. Hopefully, I'll get those graded and back to you guys as soon as I can, as soon as I get back. Today, we're just going to continue on with circles. We're going to look at our next section, which actually involves circumference of a circle and arc length of a circle. Now, you'll be receiving notes. On the front side is your circumference and arc length. The back side of those notes are going to be your area and sector area. So we'll continue that on Monday when we come back. But today we're just going to look at the front side of the notes, just the circumference and arc length. Your homework tonight, part of it's going to be with circumference and arc length. The other part is going to be your area and sector area. So you'll part of it today and finish it up next week. All right, so just to kind of start things off, still continuing with circles. Now, some of you guys are pretty familiar with what circumference is, or you've at least heard of it. All right, circumference is your perimeter around your circle. All right, so if I were to actually take a circular fence and put it up and then walk around that circular fence, that would be your perimeter or your circumference. All right, so your circumference, we'll put that up here as your perimeter around the circle. All right, so that's our first part that we're going to look at today is our circumference. There we go. All right, so perimeter around the circle. Now, your arc length is going to be a piece or part of that perimeter. All right, so a piece slash part of the perimeter. All right, so the perimeter or the circumference is going to be the entire distance around the circle. And arc length is that I was just going to take a piece of that circumference around. All right, so again, so we've got the circumference would be the entire distance around. And then an arc or arc length would only be part of that. So an arc length might only be from here to here. All right, so that's going to be part of my circle. So that's my arc length. Now, sector of a circle is dealing more with what we're looking at next week. But a sector of a circle, I like to say it looks like a piece of pie, but it's part of the area. All right, so if I were to actually draw out my center here, all right, my sector would be the piece that looks like a piece of pie. So instead of the entire area, which is everything inside my circle, a sector would just be part of that circle or part of that area. All right, so we'll just kind of put right here, piece or part of the area of the circle. All right, now with these, we've actually got some equations that we can use to find circumference and to find area. Again, area we're going to look at next week, but I'll just go ahead and give you guys the equation today that we don't flip back and forth. All right, so the first one is our circumference. All right, so our circumference, again, is the distance around. We got two different equations we can use. All right, the first one is 2 pi r, which is 2 times the value pi, which is on your calculator, which is approximately 3.14, times your r, which is your radius. So 2 times pi times r would be your radius, or you can use c equals pi times diameter. Those are actually the exact same equation, and the reason is if you take your radius, two radii together, two radius, make one diameter. So these are really actually the exact same equation, and you can just substitute parts in. So circumference is 2 pi times your radius, or your circumference is pi times your diameter. Now your area of your circle is going to be pi, there's that number pi, times your radius squared. All right, we actually don't have an area equation using diameter. It's just going to be pi times radius squared. So if you can find your radius, then that can help you find your area. All right, so those are really the equations we're going to be looking at, the main ones today. So the first one we're going to look at today is our circumference. So we're going to do a couple little practice problems with that, and we'll move on from there. All right, so let's look to the next slide. All right, now what we're going to do is we're just going to look really at A and C today. All right, B, D, and E all deal with the area of a circle, so we're going to mainly focus on A and C, which is just the circumference. We'll look at B and D next week. All right, so circumference of a circle. Find the circumference of a circle with a radius of 11 feet. All right, so we're trying to find the circumference. So my recommendation is go ahead and write down what the equation you need to be using. All right, they give me my radius, and they want me to find the circumference, so I'm going to use 2 times pi times r. Now, if they gave me my diameter, I could use pi times d. All right, but they want me to find the circumference given my radius. All right, so I'm looking for my circumference, so that's my c. So I got c equals 2 times pi times my radius, which is 11. All right, now we're going to write our answer in two different ways. One of these is going to be our exact answer, which means we're not going to be rounding, which usually means we're leaving pi in my answer. The other one would be my approximate. All right, so my exact would be leaving pi in it, so my exact would be 2 times 11, which would be 22 pi feet. So that's my exact. My approximate would be, my circumference is approximately, if I were to take 22 out and multiply it by pi, that's going to give me approximately 69.1 feet. All right, so again, we've got my approximate and we've got my exact. So I'm just going to put right up underneath here, this is my approximate value, just to kind of remind us. And again, you have to forgive my handwriting because I'm writing with my mouse again. All right, and this is going to be my exact. All right, so exact just means I'm leaving it in terms of pi, which means I'm not rounding anything. I'm leaving pi in my answer. All right. Now, the second one is just a little bit different. All right. We're looking for my radius in this case, given my circumference. All right. So once again, I'm going to write out the equation. I'm using my circumference equation, and then looking for my radius, I'm going to use c equals 2 pi r. And the reason we write this out every time is because they're going to give me different pieces, and if I just write out my equation, I can substitute in things into the right place and then solve. All right, so for this first one, or I guess the second one, we're looking for my radius, so I'm looking for my r, so I don't know what that is. And they tell me my circumference is 75 meters. All right, so that's my circumference, so that's going to go in place of my c value. All right, so I've got 75, that's my circumference, equals 2 times pi times my radius. All right, so I've still got to solve for my radius now, so now it's just going to involve some basic arithmetic. All right, so what we've got to do is I've got to get my r by itself. So you can do this one of two ways. You can first divide by 2 and then divide by pi, or you can divide by 2 pi all at once. Now, if you do decide to divide by 2 pi, make sure you put the 2 pi in parentheses. All right, so what I'm going to do is I'm going to divide by 2 pi. I mean, put it in parentheses when you put it in your calculator. So divide both sides by 2 pi. So the 2's cancel there, my pi's cancel. I'm left with my r. So that's why I'm dividing by 2 pi. So r equals. Now, my exact value, no decimals and keeping pi in my answers, my exact value would be that right there, 75 divided by 2 pi meters. That would be my exact. My approximate would be if I type this into my calculator. Now, once again, you want to make sure that you put 2 pi in parentheses if you're going to put in your calculator just like this. All right, so we're going to take 75 divided by, in parentheses, 2 pi. And if you're looking for your pi button, if you have one of the graphing calculators on the right side, just under the clear button. All right, if you have one of the little TI-30s, it's on the left side. It's an actual button. But I would use the pi button unless they tell you otherwise. So if you type in 75 divided by parentheses 2 pi, you get approximately 11.9 meters. All right, so once again, this is my exact. I'm going to put EX, and this is my approximate. All right, and so that's just using my circumference equation. All right, so now we're going to take the circumference, which again is the distance around my circle, it's that perimeter, and now we're going to start looking at arc length. All right, so let's go to the next slide, the next example here. All right, so we're going to look at arc length. So once again, arc length is a part of the circle. It's a fraction of the circle. All right, now we can think of it as a ratio. All right, so if I'm looking at this first example, the circumference would be everything around. So if I started from here, my circumference would be everything around. That's a horrible circle. All right, but that would be everything. The arc, or the arc length, would only be a piece of it. Now, the other thing we need to make sure we have clear is that arc length is not a degree measure. If I were to actually take an arc and straighten it out and measure it with a ruler, that would be its arc length. The measure of the arc is the actual degree measure. So like for this first example, the measure of arc AB is 150 degrees. the length of the arc would be if I were to take it, straighten it out, and measure it with the ruler. All right. So arc length is not the same as the measure of the arc. Those are two different things. Measure the arc again is degree. Length of the arc is the actual length of it if you were to measure it with a ruler. All right. So my arc length, we kind of have an equation. All right. Again, we're using a ratio here, and it's actually going to look more like a proportion. And we're using the fact that we know that my entire circle is 360 degrees. So going back to this first example, my entire circle is 360 degrees, but the part that I want to focus on is only 150 out of that 360 degrees. So we're using that ratio in this same example, in the same way to find the measure of my arc, or my arc length. All right, so my arc length is always going to be, I'm just going to put it, I'm going to call it Al. All right, it's my arc length over my circumference. Now that could look like 2 pi r, it could look like pi times d, anything like that. So that's my circumference. So arc length over circumference equals the measure of my arc. Remember, that's a degree measure over 360 degrees. All right, so that's what I have here. So it's the arc length over circumference equals the measure of the arc over 360. All right, so we're going to use that example or use that equation here. All right, so this first one, it says find the length of arc AB, not the measure of arc AB. All right, the measure of arc AB, like we said just a second ago, is 150 degrees. The length of the arc, I've got to come up here and I've got to use this equation here. All right, so I'm going to go ahead and write it out. So I know it's the arc length over my circumference, I'm just going to call it C, equals the measure of my arc over 360 degrees. So now we've written it out. Now we just fill in all the things that we know. All right, I'm trying to find my arc length. That's in the top left-hand corner, so I'm going to put an X there, over my circumference. Now, because they give me my radius is 5 meters, I'm going to use 2 pi times my radius, which is 5. So my arc length I'm looking for over my circumference is 2 times pi times 5 equals the measure of my arc. Now, the measure of my arc, remember, is my degree measure. That's 150 degrees. So 150 over 360 degrees. All right, we've got my proportion. We've been solving for proportions pretty much this entire semester. The way we solve it's cross multiply. So I get 360x equals, and you don't have to keep this exact. You can go ahead and round unless it says specifically exact, but most of these will just say round. All right, so then I cross multiply otherwise. So I've actually got 4 things I'm multiplying. It's 150 times 2 times pi times 5. So if we take 150 times 2 times pi times 5, I get a larger value, 4,712. We'll round that to 0.4. All right, whoops, and I forgot to put, so it's 360x. There we go. All right, so I've got 360x equals 4,712.4. So to get my x by itself, I divide both sides by 360. And when I do that, take 4,712.4 and divide it by 360, I get my arc length. We'll just say right at nearest tenth is 13.1 meters. All right. Now, let me reiterate. Arc length is a piece or a fraction of your entire circumference. All right, so if I were to actually go out and find my entire circumference, all right, so let me just kind of put that over here. My circumference, we said, was 2 pi r. You don't have to do this, it's already in the equation, but I'm just going to talk about this. So my circumference is 2 times pi times 5, all right, which is 10 pi, which is approximately 31.4. All right, so that means if I were to actually draw out my entire circumference, that would have a length of 31.4 meters. Now, the only part of that that I want is this piece right here, which is 13.1, which is a fraction of my entire circumference. And it's the exact same fraction as if I took the measure of my arc, which is 150 over 360. All right, so if I were to actually write that out, this ratio right here, 13.1 over 31.4, is going to be very, very close to, it should be almost identical to that ratio of 150 over 360. All right, we're trying to set up a ratio here to solve a proportion. All right, now you don't have to do this every time. I was just trying to reiterate to you guys that this arc length is a piece or a portion or a ratio, a fraction of your entire circumference. And we're using the fraction of the ratio of the measure of my arc over 360 degrees, since that's something I will know. All right, but again, you don't have to do this every single time. All right, so let's look at my second one real quick. And the third one you guys are going to try on your own. All right, so the second one, still trying to find the measure of my arc, or sorry, arc length. So it's arc length over circumference equals the measure of my arc over 360. All right, so I'm trying to find my arc length, so I'm going to put my x there. And we'll get to some problems where you're not trying to solve for arc length, but they give you that, and you might be trying to solve for a radius, the circumference, the measure of the arc, etc., etc. So this fraction right here, the only thing we'll always know is just 360 degrees. Otherwise, they might give us different pieces of information. All right, so I'm going to take my arc length, which is x, over my circumference, which is going to be 2 times pi times my radius, which is 15. So that ratio is equal to the measure of the arc, which we know is 90 degrees over 360 degrees. All right, so there's my proportion, my ratio that I'm setting up. So now, same thing, what we've been doing all semester, cross multiply. So I get 360x equals 90 times 2 times pi times 15. All right, so we've got 90 times 2 times pi times 15. All right, when I multiply that, once again, pretty large numbers, 8,482.3. That point there. All right, so now I'm going to take that, 8482.3, and divide it by 360. Divide both sides by 360 to get the x by itself. When I do that, I've found my arc length to be approximately, if I round to the nearest tenth, 23.6 feet. So my entire circumference is 2 times pi times 15, but the only piece of that I want is the measure of arc, or the length of arc AB, which would be 23.6 feet. So I want you guys to take a quick second. I want you guys to try and do that third one for me real quick. All right, so let's look at that third one. All right. So, same thing. We want the measure of arc, or the length of arc AB. All right, so it's this piece right here, which has a measure of 150 degrees. So I'm just going to box this in instead of rewriting that again. All right, so we're going to bring that over here. So I want the arc length, which we're trying to find, which is x, over my circumference. Now, if you notice, they give me here not my radius, but they give me my diameter. All right, so I can either use in my denominator pi times my diameter, which would be pi times 34, or if I cut this in half, half of 34 is 17. So I could also use 2 times pi times 17 in my denominator. Either way, it's the exact same thing. Since they give me my diameter, I'm going to use pi times my diameter, so I'm going to use pi times 34. So arc length over my circumference equals the measure of my arc, which is 150 degrees here. So I want arc length AB over 360 degrees. So again, I'm using the fact that I know the ratio of the measure of the arc over 360 to help solve using that ratio. All right, so same thing. We're going to cross multiply. So we get 360x equals, all right, so we cross multiply there. So we're going to have 150 times pi times 34. We're going to get a rather large number. So we're going to get 16,022.1. All right, so we're going to take that 16,022.1 and we're going to divide that by 360 degrees. That's going to give me the arc length of 44.5 centimeters. And there we go. All right, so it's a little bit of practice with arc length. So let's look at another couple of examples. Now, in these three examples, they're actually going to be giving me my arc length. and I'm going to be solving for something different. Now in this case, in A and B, I'm going to solve for the circumference, and then in part C, I'm going to be solving for my radius. All right, but because they give me my arc length, I'm still going to use that arc length equation. So if they either say find the arc length or they give you the arc length, you're going to use your arc length equation. So just for reference purposes, I'm just going to write up that equation up here again. So it's arc length over my circumference equals the measure of my arc over 360 degrees. All right, so I'm just going to refer back to this equation right up here, and we'll even highlight it for you. How about that? So that's the equation, that's the proportion that I'm going to be referring back to. All right, so once again, I'm trying to find different pieces here, but they're giving me my arc length. All right, so in this first one, they give me the measure of my arc. So from this arc right here, because that's the arc that I know the length of, that has a measure of 260 degrees, and its length is 81.64 inches. I'm trying to find the circumference. All right, so once again, arc length over circumference equals the measure of the arc over 360. Now, since I'm trying to find circumference, I can just call that x. I don't even need to call it 2 pi r because this is what I'm solving for. Now in part C, when it says find the radius, then I'm going to need to make my circumference 2 pi r. But because I'm just solving for my circumference, I can call this denominator piece x. So I'm looking for my arc length, or I'm looking for my circumference given my arc length. So it's going to be my arc length, so 81.64 over my circumference, which is x, equals the measure of my arc, which is 260, over the piece that we always know, 360 degrees. So the arc length over my circumference equals the measure of the arc over 360. Once again, guys, we're going to cross multiply. So it's actually 260 times x, which is 260x, equals, and I'm going to take 81.64 times 360 degrees, and I'm going to get a rather large number there as well, 29,390.4. All right, we're going to take that and divide it by 260 to get x by itself. So my entire circumference after I divided by 260 is 113.04 inches. So the arc was only 81.64 inches, but if I include that arc length plus the piece that I don't have, it should give me a total length of 113.04 inches for my circumference. All right, y'all take a second and try part B for me real quick. All right, you're not quite done. That's perfectly fine. Ms. Miller, if you wouldn't mind just pausing it, letting a couple people finish up. All right, but let's get to it. All right, so once again, they give me my arc length. So they're telling me, hey, the length of this arc right here is 41.87 centimeters. The measure of that arc is 200 degrees. So again, reiterate, the measure of the arc is your degree measure. The length of the arc is actually how long it would be if you straightened it out and measured it with a ruler. So they give me my arc length. All right, so that's 41.87. I'm looking for my circumference. So again, because I'm looking for that circumference, I'm just going to put my x value down there in the denominator. I'm not looking for my radius. I'm looking for my circumference, so I'm just going to put an x value right down there. Or you can put c. That's fine too. All right, equals the measure of my arc, which is 200 degrees, over 360 degrees. All right, we're going to cross multiply it once again. So 200 times x is 200x equals, and I've got 360 times 41.87. That's going to give me a value of 15073.2. All right, so 15,073.2. I'm going to divide that by 200. And if I round to the nearest tenth, that's going to give me a circumference of 75.4 centimeters. Boom. All right, and there you are. All right, so that is going to be your circumference for part B. All right, so the last one, and then we'd be done. All right, so the last one, I'm not actually finding the circumference, I'm finding the radius. All right, so in this case, my radius is still down here in my denominator. If you just put an x down here, you actually solve for the circumference. So if you did that, that's fine, but you would still need to use the circumference equation to solve for your radius then. So what I'm going to do is, instead of putting a c down here in the denominator, I'm going to actually put 2 times pi times r, because I'm solving for my radius. All right, so same thing though. I got my arc length, which is 1.57. The measure of my arc is 45 degrees. All right, so my arc length, we've got 1.57 over. Now, because I'm trying to solve for my radius, I'm going to put this as 2 pi r, because there's my radius right there. All right, again, if I just put a c down there, that's solving for my circumference, not my radius. All right, so 1.57 over 2 times pi times r equals the measure of my arc, which is 45 degrees, over 360 degrees. All right, so same thing. Let's cross multiply. All right, so first part, I've got 360 times 1.57. That won't be very large. All right, we get 565.2. All right, now same thing here. I'm going to cross multiply. Now 45 times 2 times pi times r. I've got my variable there. So 45 times 2 pi is going to give me 282.7, and there's your r. All right, because again, I've got a variable right there, so I got to make sure I remember to put that variable over here. So I'm going to divide both sides by 282.7. 282.7, so it cancels out there. 282.7, and there you go. I take 565.2 and I divide it by 282.7. That is going to give me 1.99929, so we're just going to say right at 2 feet. So the radius of my circle is 2 feet. Now again, you could have put just x down here or c, but that again would have given you circumference, and then you take that, set it equal to 2 pi r, and solve for your radius. That's just a little bit longer way of doing it, but excuse me. That is how you find the circumference or the radius using your arc length. So that's your basics for circumference and arc length. Your homework tonight and over the weekend is the practice worksheet, 1 through 7 odd, 13, 14, 17, and 18. All right, and then again next week you're gonna be doing the remainder of those using the area, the sector area. All right, but that is it for today. Hope you guys have a wonderful, wonderful weekend, and we will see you guys or talk to you guys next week. Have a good weekend, guys.